Okay. Uh, Hello. Thanks a lot for joining Q&A session for lecture 5. And today I'll try to cover two questions from Anna. One about whether testing can be automated or only checking can be automated. And the second one is there any merit in creating own test tools? For the first one, the lecture contains a link to LinkedIn post and discussion around ISTQB position paper. And unfortunately, there is a very heated debate that is not on the substance of the article, but more around how bad ISTQB as organization. Is it okay to say to a woman that she is stressed, etc.? So it is unfortunately not an idea-based discussion, but there are quite a lot of good points there. And the first thing is there is a comprehensive list from Michael Bolton on what machines should do in order to be able to do software testing. And the list goes as following. So can they do all the evaluation and learning and exploration and experimentation and modeling and studying of the specs and observation of the product and inference drawing and questioning and risk assessment and prioritization and coverage analysis and pattern recognition and decision making and designing of the test lab and preparation of the test lab and sense making and test code development and tool selection and recruiting of helpers and making test notes and preparing simulations and bug advocacy and triage and relationship building and product configuration and application of oracles and spontaneous playful interactions with the product and discovery of new information and preparation of reports for management and recording of problems and investigation of problems and working out puzzling situations and building the test team and analyzing competitors and resolving conflicting information and benchmarking. If they can, it means that machines can test, but no one really willing to commit to that thought. So it sounds very reasonable, but there are two arguments to that. The first one, if we look like 40 years back, maybe 50 years back, uh, no one expected that machine will ever be able to beat a good chess player, say, master of sports. For sure, not a grossmaster, or no one assumed that machines will be able to beat a world champion. And if we look 50 years ago, maybe more, then people will define quite a lot of things that you need to do in order to play chess well. So you need to study debuts, endspells, you need to strategize, you need to analyze your enemy's thinking, etc., etc. So you can find quite a lot of things that look like intellectual activity that only humans are capable of. Yet now we can see that it is no longer a task for artificial intelligence because it can be easily performed by uh, a relatively small computer that can beat anyone on the planet, for any human on the planet. So the chess is no longer something that can be considered. So the chess now falls completely into checking category. It is no longer testing. And it looks like many other things that previously were considered an AI task, as soon as they are solved, they are now going into checking category. Another thing we can, and it is actually a very good exercise, we can try to formulate a sentence similar to what Michael did about software testing and formulate a sentence about driving a car. And it will be quite a long list similar to that. So you need to read the signs, you need to know the rules, you need to predict what other drivers will do, you need to uh, perceive, perceive the weather around you, etc., etc. So there will be quite a long list of things that one need to do in order to drives the car, and still we can see that there is quite a huge progress in this area. So maybe at like 20 years ago, it looked like something uh, from a very distant future, and now we are quite close. So if we look at the list from Michael, then it appears that every single task from there can or already was automated to um, to a degree, but uh, say ability to solve a single task is not the same as solving 30 diverse tasks. Say if you have a program capable of recognizing cats, it's not necessarily that it will be able to play chess at the same time. So it is a good question whether we can create a model that will simultaneously be able to do multiple things. Uh, Thinking about it, so in ideal world, we can see the situation is that we have a robo helper, we have tools, and we have full control over them, and we make all decisions, and we are able to understand and explain what they are saying to us, and we can drive them, and so not the car is deciding where to go, but we can tell it we want to get from this point to that point, etc. It's an ideal world, but there are many questions of whether people can actually do it, whether we'll be able to control it, and whether we can really have responsibility and capability to monitor and to understand what's going on. There are quite a lot of uh, instances where people rely on technology and abdicate all responsibility. So in ideal world, the robots will take over quite a lot of different functions, and people will retain ability for ethics to define what is right and what is wrong, and also be able to convince machines to follow our ethical choice. Now, how probable that something. So there are two different views. One is expressed by STQB, where they use not the best phrase using fully automated testing solutions. So it is the word fully immediately opens them for intense criticism. But if we say mostly automated testing solution, it will be uh, a better position. And another is expressed by the LinkedIn post that says that software testing cannot be automated. So there are two different poles, and where we are between these two poles, I think we need to think about it as a software tester to have professional pessimism. It means that if we are thinking about something bad, then it is very likely to happen. If we are thinking about something good, it's unlikely to happen. So if we believe that uh, more that taking more control by machines and having very autonomous and highly sophisticated software is bad and dangerous, it is very likely to happen. On the other hand, if we think that it will only bring benefits to humanity, then it is unlikely to happen. So if we see that more autonomy is bad, then it probably will be the case. So as professional software testers, we need to prepare to the worst outcome. So on between these two positions, fully automated software testing solutions and uh, software testing cannot be automated, I am more on a scale that we will have something autonomous at the point when it is most uh, inconvenient to us as a species. But not sure if it is something that can be put into day-to-day practice and work on most of software testing projects. But on the other hand, so the list provided by Michael is very good, and it is a good idea to think about every aspect of it and see what we can uh, automate, so where tools can support our work and where they can't. But I think making predictions that something bad will not happen most of the time, you'll be wrong. And making predictions that something good will happen most of the times, you'll be wrong. This is my view on this question. And the second one is, can we give any examples of creating your own test tools? So there are several types of systems, and there are systems that, for example, websites, they all have a similar interface, and they are used across many industries, and it means that there will be um, there will be quite a lot of tools out there. Many people will work on implementing solutions for automated testing in web area. And it means that quite a lot of open source and commercial tools are already available. But if we go into any narrower context, for example, into autonomous driving, it will immediately happen that there are interfaces supported by sensors or interfaces supported by control units that are even well documented and standardized, but it is not something that is used by every tester on the planet, in contrast to uh, working with web. Uh, Another example is with testing for exchanges and clearinghouses. When we started to work in this area, we needed tools that support various protocols that are common in financial sector, like FIX, each, various binary protocols, um, Swift, and they are common and shared. But once again, it is not something that is available everywhere. So the availability of solutions capable of supporting it is lower. So they are not as available. And that's why you need to constantly think about implementing codecs or connectivity models between your system, your test system, and the system under test. So if we are working on autonomous car, we need to implement the API to interact with its software. If we are working in financial sector, we need to implement API to send orders and receive execution reports from the exchange. Uh, and at some point, when we have many of connections, we'll see that we need to invest quite a lot of effort into developing this connectivity parts. So the parts that interact with the system under test. And we can take available open source tools or commercial tools and then add plugins to support particular protocols. But at some point, it can happen that we have uh, more code in this connectivity modules than the test tool itself. So it is easier to create a test tool from scratch or take available open source and extend it in order to support connectivity and other functionality uh, that is required. So the main reason why we decided and why we were creating test tools over the last 11 years was that we needed them for specific context to work in financial sector, to work with low latency, high load systems. And I suspect that everyone who will ever work in any specialized context, they will encounter a similar problem. There are also another important aspect of the context. If you are working on very small application and with a very small team, then probably there will be no justification uh, into investing in own test tools. But if you work with several exchanges, global exchanges, or if you are working on a large project like creating autonomous vehicle, then I do believe that there is a strong case to develop your own test tools. When you develop your own test tool, you have full control over its licensing and also its internals. One of the articles referred in the lecture, I think it is when uh, context-driven testing approach to automation in testing. So there is a small note in that article that James Bach once encountered a project where there were 3,000 automated test scenarios and they all stopped working due to upgrades in the system under test and the test tool. So the system under test, you might have some control, but if you have no control over the test tools and you receive it from some commercial vendor externally and something breaks, then it means that everything stops on your end. And for mission critical projects, I believe it is very important to have this level of control in order to fix such problems and also to better understand what's going on. If you are taking some black box tool and connect it to something, you might not understand how the actual interaction between the test tool and the system under test works. And that's why you will not be able to test it properly. For example, in Exchange domain, what we have encountered that the best vendors of Exchange platforms, they provide their own test tools and their own injectors to the clients. And then clients take these injectors, connect to the system under test, and see that everything is fine uh, because it works um, in exact form and exact sequence as vendor intended. But it's not what happens in the real world. And by using external test tools, the clients are not able to explore things around it. So it is like bad testability, where instead of highlighting problems, you're hiring problems. So that's why we believe in building the test tools. After 10 years, we decided that we need to have more open architecture for the test tools. So our latest one, TH2, we are trying to make sure that it is built from microservices, that it is possible to take not the whole tool, but just parts of it. And it's also possible to change various parts of it, etc. And it is in GitHub, it is in open source, and we believe it is the way forward. So I believe for every complex project where there is substantial scale, it is a good thing to build your own test tools. It is one thing. Another thing is when it is also a good idea to have a tool that works in different uh, contexts, then it will also benefit your project. For example, we've encountered in many exchanges, we encountered that their test teams built the tool, their own tool, they have full control over it, and it is good. And they use it for testing, and they have efficiency from the situation where they do not need to pay licenses, etc. So it's also very good. The problem is that the tool is very fine tuned to a single system. So if, for example, you build a tool that works only with one type of autonomous vehicle, it will always be limited. And that's why such a good idea for LG simulator to work with both Apollo, AutoWare, and other tools. So the test tool should be used not for a single system, but several systems. Thank you. Not sure if it was very clear, but on both questions, we are spending quite a lot of time internally, constantly thinking about these two questions, whether the software testers will end up on autonomy scale, and where is the merit in building something instead of buying something. Thanks a lot for your questions. Uh, do you have any other questions? Should we call it a day?
So do you have any other questions? Or if not, then as Josef mentioned, we can finish Q&A session.
Please do send any additional questions into Telegram channel, and we'll be happy to cover it one way or another. Thank you very much. Thank you for your time, and thanks a lot for staying with us. Thank you.
Thank you.